Video for my Algebra 3 prerequisite chapter 2, in which we're going to involve ourselves with the rules of exponents and try to simplify expressions involving exponents. So we're just going to run through these pretty quickly here, starting with the product rule. When we talk about the product rule, we're talking about the product of two things that have the same bases but maybe the same, maybe different exponents. But we say when you multiply two things with the same bases, what we'll do is we'll keep the same base, but we'll add the exponents. And this would be kind of like if we said like 3 squared times 3 cubed, we'd have a total of 5 factors of 3, so we say like 3 to the 5th, okay? So what you're seeing down here are a couple of examples, but we would say since we're multiplying two things with the base of 3 here, we would just say that this is 3 to the 3 plus 2. It's just that we get pretty quick at this and we just say, well, then that's 3 to the 5th. And if you can evaluate this, you probably should. You know, this would be 9 times 9 is 81 times another 9. Off the top of my head, I can't think of what that might be. 9 times 9 times 3. 9 times 9 times 3. But we would get 243, okay? Whereas if you were to see, say, an expression with variables in it, we would say you start with the coefficients in front, but we say 4 times 10. This would be really easy to operate with. Here we say 40, and then we'd have x to the third times x to the second would give us x to the fifth, whereas y to the fourth times y to the sixth, that would give us a total of 4 plus 6 would give us 10 y's there. So this would be our simplified expression. Likewise, when we talk about the quotient rule, we say the quotient of two things that have the same bases. What we do is we subtract the exponents, and I hope you can see this here. It says b to the m over b to the n is equal to b to the m minus n. In other words, we always take the top numerator, or the numerator exponent away, or sorry, we take the denominator's exponent away from the numerator's exponent, assuming that b is not equal to 0 itself. And the reason why we do this, you know, if we had something like x to the third over x to the second, really what we're saying is we have 3 factors of x on the top and 2 factors of x on the bottom. And so really what we're saying is that 2 of these essentially cancel out, and we'd be left with just 1 on top. But we could have obtained this just by saying x to the 3 minus 2 is equal to x to the first. So when dividing exponential expressions with non-zero bases, we're just going to subtract the exponent in the denominator from the exponent in the numerator. So we're going to use this relationship here, and we say, well, negative 3 to the sixth over negative 3 to the third, this would be equal to negative 3 to the 6 minus 3. In other words, we would get negative 3 to the third, which comes out to be a negative 27 when we evaluate that. But this is our simplified expression. Likewise, if we were to look at this over here again with variables, we'll just start with their coefficients. We say 27 divided by 3, well, that would be equal to 9. Whereas we get x to the 14th over x to the third, well, 14 minus 3 is 11, and we say, well, y to the 8th over y to the 5th, that's going to give us 8 minus 5 is y to the third. So here's our simplified expression. So let's go ahead and talk about the zero exponent rule. We say if b is any real number other than 0, then b to the 0 is always equal to 1. And this kind of follows the rule we just looked at here. If we were to say hypothetically b to the 2 over b to the 2, we know that anything divided by itself is equal to 1. But following that rule we just talked about here, basically what we obtain is this fact that b to the 0 would be equal to 1. So we say here are some examples involving simplifying using zero exponent rule. Essentially 8 to the 0 would be equal to 1. Negative 6 to the 0 would be equal to 1. I want to point out this though, when we say negative 6 to the 0, where the negative is not included in the parentheses here, like we have negative 6 to the 0 over here, then really what we're saying is negative 1 times 6 to the 0, which comes out to be, you know, exponents first. We get negative 1 times, well, zero exponent rule says 1. So we get negative 1 in this case. And likewise over here, parentheses matter. So 5x, all of this to the 0 would be 1, whereas if I were to say 5 times x to the 0, we would have to evaluate the x to the 0 first. So we'd really get 5 times 1, which leads us to this 5, okay? So let's build on next. We have our negative exponent rule. We say if b is any real number other than 0 and n is a natural number, then we say b to the negative n is equal to 1 over b to the n. And what I really want you to understand here is basically we say that this is over 1. What we've done is we've taken the base here, b, and moved it down to the basement. You notice the result here is that its exponent has switched its sign, okay? You know, if I were to give an example of what this might look like, if we had, say, b to the second over b to the third, we'd have b times b on top, and we'd have 3 b's on the bottom. And basically what I want you to see is, using our quotient rule here, we would get b to the 2 minus 3, which is equal to b to the negative 1. Whereas if we were to evaluate this here, we say, well, these two factors cross out with these two factors, and we get left with 1 over b. So you can see that b to the negative 1 over 1 is the same thing as 1 over b to the positive 1. We can just move this around. So to look at these expressions here, we say 5 to the negative 2. Well, another way to write this would be able to say, well, then that's the same thing as 1 over 5 to the positive 2, or 1/25. Likewise, if we said negative 3 to the third power, the first thing we're always going to do is we're going to rewrite this so that it has a positive exponent. So we get negative 3 to the positive 3. In other words, get 1 over 27, and that would be a negative 1 over 27. Notice here that we start with a negative exponent in the denominator. All we'll do is we'll just move the base upstairs. When we say 4 to the positive 2 over 1 is the same thing as this right here. In other words, we get equal to 16 in this case. And then last but not least, we have 3x to the negative 6y to the fourth. Well, I noticed that the only factor here that has a negative exponent is just the x. So what we're going to do is we're going to move it, and we end up with 3y to the fourth staying on top, whereas our x to the sixth, it moves down here, and you can see that our exponent would just become positive, and this would be our simplified expression. So in general, we say given a negative exponent here, it's kind of hard to see. We say this is a b to the negative n here. It's 1 over b to the n, whereas if we were to start with a negative exponent in the basement, we would just move that back up to the exponent, move the base up to the numerator, and then make the exponent positive. And that's going to be our general method for dealing with negative exponents. So let's go ahead and expand on this a little bit here. When we say the power rule, what we're really referring to is a power to a power. In other words, we have some exponential expression being taken to another exponent. And so you can see that in this case, what we'll do is we'll just go ahead and multiply the exponents. And to give an example of what I might be talking about here, we say x to the second to the third. This would be the same thing as x squared times itself 3 times. And really all this is just an expansion of our product rule. It says now you're multiplying things with the same basis, you better add their exponents. So we would get this, and we're multiplying it by itself 3 times. So really we could just take 2 times 3. And that's exactly what this says here. So looking at these, say, examples down here, we say 3 to the third to the second. Writing this out would be 3 to the 3 times 2. In other words, though, we could say 3 to the 6 and skip to that pretty quickly there. And generally, we would evaluate that if you can, but I'm going to leave that for now. How about y to the 7th to the negative 2? Well, this is just multiplication again, except for this time I'm just going to say, well, then I get y to the negative 14. And again, using our rules of exponents, we say, well, I would like for that to be a positive exponent if I can. So we're going to move that downstairs, that base, and make the exponent positive. And then last but not least, we have b to the negative third to the negative fourth. When you multiply those two exponents, power to a power, we're going to get b to the 12th, which is kind of a nice thing because it means we don't have to move things around, okay? So let's talk about a couple of quick rules here, products to powers and quotients to powers. When you have a product of things inside, say, a quantity here, and you're raising that entire quantity to an exponent, you'll notice that every single factor, the a and the b in here, is being raised to that power. It's really important that we raise everything in the quantity to the power here. So this is just like our, product rule, except for, a little bit different. We're taking the whole product to a power. So when I look at this here, I want to point something out. The important thing is that we have two factors in this product. We have negative 4 and x. So when I rewrite this, if I'm going to be technical about it here, I'm saying, well, the negative 4 gets raised to the third power here. But so does this x. Everybody in here is going to be raised to the third power. So a negative to the third power is still going to be negative. And 4 times 4, which is 16 times 4, is going to be 64. So I get negative 64. And then we get our x cubed. So you notice that we cubed every bit of this in here. Likewise, if I were to look over here, we would say negative 2y squared to the fourth. Well, I got to take negative 2 to the fourth. I also have to take the y squared to the fourth. And again, you can see how these rules start to stack up. We say, well, I'm going to get a positive 16 here. And I get a power to a power here, which I would say, multiply the exponents, y to the 2 to the fourth. We're going to get y to the 8th. Okay, so 16y to the 8th. Quotient rule is very similar to power or product to a power rule in that if you had a quotient to a power, we need to take everything on the top of that quotient to that power as well as everything in the bottom of that quotient to the power. So the a gets taken to the n, the b gets taken to the n. So when you look at expressions such as these here, we say negative, 3 over x to the fourth. I'm going to go ahead and include that negative on the 3 up here. We're going to say that's the negative part of this quotient. Basically, what I'm going to say is I get negative 3 is going to be taken to the fourth, but I'm also going to take x to the fourth. We're going to do both the top and the bottom to the fourth power. And on the top we get 3 times 3 is 9, and you do that again, 9 times 9 is 81. It's going to be positive. On the bottom we just get x to the fourth. Over here in this expression, we're going to have another combination of rules here, but we say take everything on the top, that's the x squared, to that third power, whereas we're going to also take everything on the bottom to the third power. So we get x to the second to the third, gives us x to the sixth, and 4 to the third power there, that's going to be our 64. So this is our simplified expression. So for our final little bit here, I'm going to basically point out this little diagram. This is a good thing to kind of have in your back pocket, but basically it kind of boils down how you would simplify exponential expressions. Pointing out some things like, if necessary, simplify powers to powers using, this rule here, or, removing parentheses if at all possible. So we have a product to a power or a quotient to a power. We want to get rid of parentheses. Also this, if necessary, be sure that each base appears only once. So if you have b to the m times b to the n, they have the same basis. We only want to write it as b to the single, one single b to a power of things. And the same thing with quotients. And last but not least, anything to a 0 power, let's write it as 1, and anything with a negative exponent, we really, really want to move that so we have positive exponents. So to end this video, let's take a look at these last 4 expressions here. We want to simplify these and kind of refer to what rules we're using. But I notice here on this first one I have a product, and I'm taking that product to this power. So it's a product of the power rule, so we say 2 to the 4th, and then I would have x to the 3rd to the 4th, and I would have y to the 6th to the 4th. And when we simplify all this, 2 to the 4th is going to give us 16. We have a power to a power here, so we're going to multiply the exponents. So we say x to the 12th, and again another power to a power, so we 6 to the 4, we get 24. So here's our simplified expression here. Taking a look at letter B, let's go ahead and start with this. We're multiplying 2 expressions here with exponents. Let's go ahead and start with the coefficients. Negative 6 times 3 is going to give us negative 18. And when you take x squared times x to the, now that's the first, we're going to say x to the 2 plus 1. Okay, that's our product rule. We're going to add the exponents. We get x to the 3rd, whereas y to the 5th times y to the 3rd, we add those together, we get y to the 8th. Okay, so looking at these last 2, looks like we have a quotient here. We're going to go ahead and again start with the coefficients. We say 100 divided by 20. Well, 20 goes into that 5 times. So we're going to say x to the 12th over x to the 16th. Now our rule says if you have a quotient of 2 things with the same basis, we're going to take the bottom exponent away from the top. So 12 minus 16, we actually get a negative 4. And y to the 2 over y to the negative 4, we get y to the, I might even write this out, 2 minus negative 4, because what you end up with is actually positive. So what we get here is 5x to the negative 4, y to the 6th. Now we need to finish by, again, we said we want to make every negative exponent positive if at all possible. So we're going to move that downstairs. We're going to say 5y to the 6th is going to stay in the numerator, where our x to the 4th is going to move downstairs. And then last but not least, if we were to, say, take this quotient to a power, remember, everything in the top of the quotient is going to be raised to that negative 2, and everything in the bottom of this quotient is going to be raised to the negative 2. So on the top we had 5x, on the bottom we have y to the 4th. So borrowing from all of our rules now, we say on the top, we have product to a power, so we're going to get 5 to the negative 2 times x to the negative 2 on top. On the bottom, we have a power to a power, so y to the 4th to the negative 2. We're going to multiply those exponents, we get y to the negative 8. And it seems to me like everybody has a negative exponent here. So what we're going to do is we're going to move all of these bases. So on the top, we'll have y to the positive 8th now. And on the bottom, we'll have 5 to the positive 2, which is 25, whereas we'll have x to the positive 2. But these are rules of exponents. We want to be really, really good with them. Cheers.